What even is artificial intelligence? You've probably heard of it. It's everywhere right now. So, from WhatsApp chats to university debates to dramatic YouTube thumbnails. But if you stop and ask someone to define AI clearly, most people pause. Is it robots? Is it ChatGPT? Is it something to be excited about or terrified of? So let's clear that up because AI isn't just hype or Hollywood, it's here and you're already using it when you type a message, when you browse Netflix, or you unlock your phone or apply for a job. But to understand it properly, not just buzzwords, we need to start from the ground up. So, at its core, artificial intelligence refers to machines or systems that can do things that would usually require human intelligence, like recognizing patterns or solving problems or learning from experience. But here's the key, it doesn't mean the machine thinks like a human, it just produces outcomes that look like intelligence, often through pattern recognition and prediction. And AI isn't one single technology. It's more like an umbrella term covering different systems, methods, and even different approaches. So today, what we mostly have is something called narrow AI, systems that are designed to do just one thing very well, like detecting spam or recommending music or generating realistic images. Let me explain that with a single metaphor. So imagine you're teaching a child the difference between a cat and a dog. You show them hundreds of pictures. Some are cats, some are dogs. Now, over time, they pick up on the patterns, so whiskers or tail shapes or the ear positions, and eventually they get pretty good at it. And that is exactly how many modern AI systems work. We give them large amounts of labeled data and they learn to predict patterns based on that. That is called machine learning. But there's a major difference. That child understands what a dog is. They've seen one, maybe even touched one. They know that it barks, it wags its tail, and it chases different things. But the AI, it doesn't know any of that, right? It doesn't know what a cat is. It doesn't know anything. It just sees numbers, patterns of pixels, and it learns statistical relationships between inputs and labels, not meaning, not emotion, just maths. So when you hear people say things like AI wrote this essay or AI passed a medical exam, just remember, it didn't understand the topic. It just predicted the most likely words based on what it has seen before. But it is incredibly impressive, but it's not the same as comprehension, which is what human beings do. And that is a crucial distinction. Now, let me share a quick story. So, back in 2016, I joined IBM as a graduate consultant, working as a business analyst, project manager, data scientist. This was around the time IBM Watson was everywhere, a system that had beaten human champions on the quiz show Jeopardy and was being marketed for everything from cancer research to customer service. It was my first real exposure to the world of AI and very up close. And what I saw was this huge promise and real power, but also huge limitations. Yeah, Watson could process thousands of documents in seconds. It could pull out relevant phrases, find patterns, and even surface different suggestions. But it didn't understand what those documents meant. It wasn't a doctor, it wasn't a lawyer, and in fact, some of the most hyped up applications, like Watson for oncology, didn't deliver the impact people expected because data quality, human nuance, and real world messiness got in the way. So I learned early on AI is powerful, but it's not magic. And sometimes when we project human intelligence onto machines, we misunderstand both. That's one reason I wanted to make this series because too many people either overestimate or underestimate AI. They either think it's going to replace everything or they assume it's all just smoke and mirrors and isn't going to go off anywhere. But if you understand how it actually works, you're less likely to fear it or ignore it, and you're more likely to use it well. So here's what we've established so far. Today's AI is mostly narrow, not general. It's built using machine learning, especially with large data sets and supervised training. It recognizes patterns, it doesn't think, it doesn't have goals, beliefs, or desires, but it can still transform industries if applied well. Let's now zoom out. So, there's been a lot of talk recently about a report titled AI in 2027, and it predicts that just in a few years, we could see AI systems replacing large chunks of white collar jobs, matching or even outperforming humans in key decision making tasks, and automating entire functions in education, healthcare, logistics, and even improving themselves in a loop, sometimes called recursive self improvement. Now, some people call it hype, and others say that it's already happening. So, how realistic is it? Well, in typical economics fashion, let's start with the basics. So, supply and demand. Right now, there's huge demand for AI across governments, businesses, startups, and even NGOs. Everyone wants to do more with less, and they want to do it faster, cheaper, and smarter. But there are constraints. AI doesn't appear out of nowhere. To train a large model, you need computing power, like energy hungry GPUs and server farms. You need data, which is high quality, diverse, and relevant data sets. You need people and expertise like engineers, researchers, data scientists, and you need hardware supply chains, including materials and chips that are geopolitically sensitive. So supply isn't infinite. And when you combine high demand with constrained supply plus enormous potential reward, you get something very familiar in economics, a race. And this is where the geopolitics comes in. Countries aren't just investing in AI because it's cool, they're investing because it's strategic. AI has the potential to shape economies, influence elections, manage infrastructure, and even impact defense and national security. It's the new oil, the new arms race, and that means that incentives sometimes can get distorted. Companies, they want to move fast. Countries, they want to win. And that can lead to decisions that might prioritize speed over safety or dominance over ethics. And here's where behavioral economics comes in. So, people like Dan Ariely, who's written the book Predictably Irrational, has shown that humans are not purely rational decision makers. We chase short term gains, we copy others, we underestimate risks, and we justify things after the fact. So apply that to the AI race. If a company thinks if we don't launch this model now, someone else will, they'll probably just go ahead and launch it. If a country believes falling behind in AI could compromise security, they'll likely take bold, fast action. Now, this isn't about good or bad, it's about incentives. And that's why it's so important, especially for students and graduates, to not just learn the tools, but to also understand the context that they operate in. Because AI isn't just a technical field, it's a human one. It reflects our goals, our biases, our data, and our decisions. So let's end with this one thing. When someone says AI is taking over, ask them which AI and in what context and why now. Because the future won't just be shaped by AI alone, it'll be shaped by the choices that people make about AI. So, in the next episode, we'll explore the difference between narrow AI, which is what we mostly have today, and the dream of general AI, which is also referred to as AGI, where machines might one day match human thinking, so almost like a superhuman robot. Now, what is real? What's the myth? And what happens if we cross that line? Well, let's find out. See you in episode 2.